Oh, I am live. This is nice. Hopefully someone actually pops in. I am to close that because life. I'm gonna keep that on top, I think. More actions, keep above others. Okay. To youtube.com/user scout I might as well share this link to a couple of people. I didn't save my GitHub. That's probably why. Oh, customize links, edit links. There we go. Yeah. Oh, looks good. Alright, that's a live stream. Sweet. What is this? My disassembler. And I decided to live stream. If you really want to watch. Let's see. OBS seems to be doing fine. My computer's doing fine. Don't even hear the fan. Let's see. Does he want to? Why is that? Probably why. I don't know which is what. Go here and take the chat. Okay. Yet again. There we go. Everything is visible. It's give above others. Alright, so yes, I'm live. I have no idea if anyone is going to actually send chat message. Let me see if I can pull up the chat on my phone, because I would rather have it there. Oh, yeah, I'll also mute my phone to process. I have a live instead of the go to desktop view. That is not what I wanted. A desktop site. Yeah, there we go. Let's this. Can I actually like not really hack this? But no, like I can't. It looks like I'm just gonna have to go to the YouTube app and do it that way. Cause yeah. I think anybody's gonna actually watch me, but we'll see. We shall see. Yeah, I will have that going. Alright. So, I don't know if anybody can actually see my screen. You can kind of see it. Yeah. Stop it. Stop. Oh, my word, YouTube. Can you not? Alright, so it looks like you can see it. Nailed it. Yeah, because earlier, I set it to 720p. Oh yeah, you can definitely read that. The only reason I can't read it is because I don't know. I have no idea. Yeah. Alright, you can definitely read that. Yeah. Alright, so now that I know that everyone can read, well, I don't know if anyone can read. Who knows, maybe we're in the Matrix. Anyways. That's like the weirdest comment ever. Oh my word. Alright. So, I have no idea if anyone's gonna watch this or even leave a chat if they do. And I hope I don't make YouTube mad because I use Electron for the whatchamacallit. Just saw something, I don't know what it meant. Now, I hope YouTube's not mad at the fact that I use Electron for the thumbnail, yes. Because, well, I mean, the reason I'm using Electron is because if I go down to console, and if I go down to eZ80 assembler, that is on the right screen. I do have two monitors, so you might see me go in and out. I've been using my second monitor for displaying the debug thing. Yeah. I'm not actually close out Discord because I don't want people seeing my Discord. I'm in a private chat with someone. Actually, I don't even think they can. Well, obviously not now. I mean, it's not anything here worth seeing. Yes. I mean, maybe my binary clock in the background. Oh ho ho. That's how you know you're a nerd, if you have a binary clock and a graphing thing. I have no idea. I was really just playing with KDE stuff. Anyways. Oh, I'm tired. This is the current interface. It actually, I pretty much restarted. Here in the this what you call it? This text editor. There we go. Text editor I'm using. It's Atom. If you just go to atom.io, actually, if I atom.io, we bring that sweet goodness over here. Yeah. So this is Atom. It's a text editor. Funny thing, also, code was loved by GitHub. It's made by GitHub. And also I think Linus Torvalds actually was, I don't think he's the author of GitHub, but he's definitely someone who's contributed. So yeah, he's a person. Yeah. Atom is built by GitHub, so if you don't know what GitHub is, then you got a lot to learn. Atom's really nice. It has a package manager, and you can get a whole bunch of stuff. Like, Actually, I wonder if it has on here. What is Zig? I'm gonna look at that in a second. Oh, it's not up here, but mini map. Yeah, there's a mini map for Atom. It's a plugin you have to install, but I don't know what this is. Wait, is this? I don't know. Oh, there's other things. Interesting. I'll have to look at that. Zig. That's it. You can also get different themes. I am using. What theme am I using? I have no. Oh, SETI? I don't know. SETI is like a material design theme, related theme. So, anyways, yeah. Here's Atom. Funny thing is, though, what I'm using, if you look here, this is Node.js. This is just JavaScript that is run from like console. Oh, okay. And there's my fan. Because my computer doesn't like me. I'll probably close this tab out here in a second. But yeah, this works with Electron. You use Node, and you basically launch Electron with Node, and then you get a regular, HTML window. Something I haven't tried. I'm just gonna see if I can actually open this up in my web browser, if it will give me any issues. Yeah. Yeah, that won't work. If I go to my JavaScript, there's a couple lines. I did not edit anything. I don't know what it's doing. Yeah. These two lines up here, this is this require thing, that's like a Node Node exclusive token, you could say. I mean, also I use tilde for my terminal most of the time. But if I go into like a Python prompt, you can import packages with Python, so like import curses, and whoa, you have curses. If you reload it, if you just try to use curses, it won't work. Import curses, then try to use curses, and it pops up as module. So right there, it's a module. Same way with Node. Let's see, actually, if I exit and quit, maybe. Aha. Yeah, programming, web, eZ, disassembler. So you can see here, actually I'll hide that. You can see I get these two files, opcodes and opcodes full, and you can see I'm getting it from this file, looking at these two files. I'll explain what they are in a second. I don't want that. Do I? How do I close that? Anyways, but I'm running this in the main folder. Why is my CPU fan like going insane? Anyways. Right, there we go. Let's calm down. Anyways, if I do what we have there, wish I had a syntax handlighting. Anyways, opcodes equals require. And then because it's in the current directory, we'll just do one dot. Opcodes.json. No, for some reason it doesn't want to work. It's probably just the exit return thing. I don't know if this is too hard to read for YouTube, so I'll just disable transparency. Because, you know, I'm all about that quality. Just listen to my mic. You'll know that real quick. Anyways, actually, we need to do that. Clear node. Cannot type. But if I do opcodes, it's not defined. Const opcodes equals fire. Codes.json returns undefined. Oh, because you're saying a variable. Then if we do opcodes, you can see it gives a lot of cool fancy data. So yeah, you can see how that's a lot like, I swear if I do that again, I'm literally gonna hit my F12 button is the same as my airplane mode button, and I have to hit, yeah, watch it. Good enough. Anyways, yeah. Anyways, we'll load the JSON data from the files, and then you can use that as a JavaScript dictionary. I'm just gonna assume, you know, a little bit. I don't even know who I'm talking to. You, the viewer. Because nobody's watching. Sad face. Anyways, yeah. This creates JavaScript objects. I mean, from my research, pretty much everything is an object. Like, legit, my computer science professor said everything's an object. And we're working with PowerShell. And I'm not going to even look into it. But he said everything's an object. And I think... brain fart. Yeah, let me just show you. If I go to here, this is the one thing I forgot to say. This editor, Node.js, or not, Electron, not Atom, yes, Atom, ATOM, the text editor. You can see it there, Atom. This text editor is built on Electron. And Electron's a thing I'm using for this. That's why I showed off Electron earlier. Or I showed off Atom. Atom uses Electron. Atom uses Electron. Electron uses Node. Anyways. So back to what I was saying. So I've been with this project, I've been playing with like custom HTML elements. In my computer science courses for college. I'm just gonna turn off the lights real quick. In my computer science courses at college, we went over XML. Actually, I'll pull it up. GitHub.com. So we were going over XML because we're learning classes. So let's see, this is an example XML file we had, and we were going to make like a class for it in PowerShell. So we were just looking over some of the data. Any raw. Actually, let me save as. Actually, I think I have it somewhere. Do I have it just cloned here? No, it doesn't look like it. Yeah. Click on this. Let's copy that. and then API doc. So yeah, you can see oh, cool. Let's just control you. So you can look at it XML here of someone leaves a comment or whatever and wants a link to the XML. I could provide that or whatever. Anyways, so we're learning in PowerShell how to make like classes and stuff and modules. So we're gonna do a pets module. We're gonna make a class dog. Synopsis gives information about the class, properties about that class has, methods, remarks. I actually made my own example. We had an implementation challenge where we were, actually let me do this. We were trying to make a, we learned about functions, and then my professor proposed a challenge. Okay, that doesn't work. I want to remove these. Okay, there we go. I don't know. You want to make an implementation challenge where we had to implement a function to convert between Celsius, Fahrenheit, and Celsius. I don't know if it's this. It converts between Celsius, Fahrenheit, and Kelvin. But because I'm a smarty pants who went ahead, not really went ahead, I've been doing programming for a long time, so I'm already ahead. I was ahead before I started. Anyways. Oh, why am I doing this? Why am I stupid? Here's the actual challenge. Implement a function that will accept a numeric argument to represent a temperature value and a string argument to represent a unit of temperature measurement. Temperature argument should be any integer or real number. Unit argument should include Celsius, Fahrenheit, Kelvin. There he kind of implied what to use for the units. The function should display the given temperature in each of the other systems. The return value should be true if the conversion was successful and false otherwise. Oh shoot. I legit failed this. It wasn't a test or anything, so but just rereading it, the whole thing it wants is true or false based on whether it worked. And right here with these methods, because this is what will convert it, it just wants to know if it was successful. I mean, it does say the function needs a temperature value, i.e. a number, numeric argument for a temperature value, and then a string for the unit, but I have different functions for each. And I could make it so that you only put in, a string, but anyways. But yeah, long story short, we are using XML. You can see here, this is the XML, and then we do have some CSS. I actually updated because I wanted a quote. And you can see here, there's a quote, because we're doing raw XML. So because we're doing XML, I was like, all right, HTML is just XML, but fancy. I mean, the browser even understood that XML. And so I should be able to parse through XML with JavaScript. And it turns out I sort of can. I mean, I think you can, XML just follows the DOM or whatever. So you can see here, well, that's my old stuff. But I would just have a file input. So I click that, it opens a file prompt, a button to parse the file, which I used to have available, but now I don't because I disabled stuff. But yeah, what I'm working on, I was doing it before. Let's go through the mini map. Right here, if you want to pause the video and look through it, I had different custom elements that was supposed to be for different things. The disassembler, and yeah, it worked. It worked, and it was pretty good. But you see, the way I programmed it, actually, if I do this real quick. Easy. No. There. No. Okay. Yes. So right here I have final ROM. By xxd final ROM plus. You can look at all the raw hexadecimal data. By the way, the eZ80, which is a processor. Alright. eZ80. Yes, very good. Alright, so this is just Wikipedia. The Zilog eZ80 is an 8-bit microprocessor from Zilog, which is essentially an updated version of the Z80. You can see over here an eZ80 and a TI-84 plus CE. I have a TI-84 plus CE, and it has this processor in it. So if I were to tear apart my processor, tear apart processor, that works. If I were to tear apart my calculator, this would be at the center of it. I believe this is. There are two calculators that came out. I mean, the scope of how long TI Texas Instruments have been making calculators, I would say fairly recently. Like, you see this one everywhere, TI-84 Plus. That was released in 2004, so this was a complete decade after. Yeah, this was released in 2015. This has the eZ80 processor, but all the older ones have just Z80. So the only other one the only other calculator from TI, I believe at the moment, that uses the eZ80 is not. Oh wait, where is it? So it's not that. It's not the color silver edition. It's not the silver edition. It's not the plus. Oh, they have different ones down here. Oh, okay, this is it. TI-83 Premium CE. Yeah. You can tell this looks a lot like the other one, the TI-84 version. This one boasts an eZ80. I believe that's the only calculators that. No, they also have a Python one, but I believe that's only French. Côté. I don't actually speak French. Dessin, distrib. I'm gonna try. I'm gonna butcher all of them. Or I did butcher all of them. Let's just say that. Yeah. You can actually program Python, the French one. That's only the Python edition version though. It doesn't say when that came out, but this uses the eZ80. So yeah, everything you can do on the one calculator I have, which is the eZ80 or TI-84 plus CE. The assembly on there should work on that other TI-83 Premium C, whatever it is. But yeah, this is the one I have. I have a white one. But yeah, here's information about it. And if you don't know, there's this thing called assembly. All right, my dude. This thing called assembly. Let's just what am I? ASM Sudoku. ASM. So here's an ASM file, assembly. I say ASM, even though I should say assembly, because I'm not typing. Quicker type ASM. Anyways. But if you see like right here, there's just this different information, and for a second I was confused. I'm like, wait, I wrote more code in this. Yeah, this was probably like 2 weeks of work, this file. Probably longer, honestly. Yeah, assembly gets, there's a thing called assembler. I have an assembler, spasm. Actually, can I man? Hope. There you go. So you can see spasm, it takes input and output files. Well, it takes an input file and writes to an output file. It takes, or you can set it to take eZ80. But what this will do is this will take the assembly, so all this stuff here, take instructions like LDIXBC. It'll take that and convert it into an opcode, which basically is just fancy for the hexadecimal for that instruction. And instruction is an actual process the CPU carries out. So when I'm talking about an instruction, that's like the lowest level concept you can get of code. Assembly and instructions and all that. I mean, instructions, not the best terminology, but assembly, yeah. Most computers nowadays use the x86 64 assembly, or I don't know if there's a 64 assembly or if it's just x86 64. By the way, this is the user manual for the TI, not for TI for Plus CE, but for the eZ80. You can see 411 beautiful pages of processor documentation. But I'm gonna go down to, I'm gonna pull that back up. Just find, yeah. We'll take this LDB04, and that $sign means hexadecimal. You can also use 0x and then whatever hex digits, but yeah. So you can see LDB04. So we're gonna scroll through this list, and this is what the assembler does basically. And scroll through this list, and then it will see this R. So if you notice, there's just that B. There's a thing called a register, which if you're familiar with programming, it's like a variable, but it's an actual hardware, a piece of hardware inside the CPU. So it's a micro hardware. Nailed it. We'll take a register. A register will just store data. And actually, if I have an ADHD moment, we go up to registers. There's two different modes on TI-4. There's ADL mode and Z80 mode. Z80 mode makes the processor work just like a Z80 processor, which is the one before it, which actually, if I quickly not do that, but if I just Google Z80, I'm just scrolling through this because I don't know what I'm doing. Notable uses. So yeah, I would like to point out that the Z80 was used like during the 70s and 80s. So this is a nearly 4 decades old processor, and that it's still pushed today. Like, If you go to an American public high school, I mean, you're probably going to end up using a TI-4 Plus. Yeah, TI-4 Plus. And that has a Z80. So that's like a 4-decade old. It's almost half a century old. Just think about that. Your calculator is using the processor. I mean, the processor itself isn't, but the designs for it, that's all like a decade old, but it's using a Sinclair computer. Echo Vision? I don't know if that's how you say it. A different version of the Z80 to Z88. And I wish I could say I knew exactly what that is like and the difference, but the truth is I don't know. Real one I'm looking for though. It's a Commodore 64, because a lot of people I feel like would know about the Commodore 64. I mean, I even knew of it. There's a guy on YouTube that I like to watch, but CPU, it does have a I thought the Commodore had eZ80. Guess not. Okay. I guess it wasn't quite. There's a cool diagram. The Commodore 64. I swear it had a Z80 in it. I don't know, maybe it was a computer after it. Yeah, I thought it had a Z80 in it, maybe not. But anyways, yeah. But I mean, still, it was back then. Anyways, 1 minute. So yeah, Z80 mode. It works like a Z80. And then you get more Z80 mode. Yeah. Then you get, here's kind of what I was looking for. So this is ADL mode, which is like, I don't even remember what ADL means. Say, oh my bird, come on, where art thou? Where's the definition for ADL? Oh, what's ADL mean? I might just have to scroll. Address and data long. That's what it stands for. Address and data long. And long story short, the Z80 mode, you can have like everything in 8 and 16-bit. Well, these registers are always, these ones here, the individuals are always 8-bit. But like the address, so in order to go to a place in a calculator, you use a 16-bit value, which turns out to be 2 hexadecimal characters, digit, or no, it's 4. Is a hexadecimal character digit is 4 bits, and then, right? Yeah. A 16-bit value in 4-bit characters. It's so 4 characters. Well, that's how you do stuff with the Z80 mode. So if you were to program, if you were to try to learn assembly for like the TI-4 Plus, or basically any of the calculators in the TI-84 line before the TI-84 Plus CE, if you were to use any of those, that would have the Yeah, words. Yeah, that would only have 16-bit addresses. So in order to get to any memory, actually, let me open up CMU. That is probably not something I wanted. CMU. Yeah, run that, please. Ubuntu mice. Kidding, that's weird. I thought this was, well, I know this is chopped off. This is how I learned assembly, pretty much. So this is the disassembly here, and this is pretty much what I'm trying to do. And I know this has just been like learning programming with Caleb, with me. My name's Caleb, by the way. I don't know if people on the internet know that, maybe. Probably parent. But you can see these are the instructions like before I had the instructions. And here's the hexadecimal code, but you can see these addresses are in 6-bit or 16 bits, 6 hexadecimal characters. That doesn't change. And I take it out of ADL mode. You can see over here with the stack, you can see all these addresses are in 16-bit, but when you not do stack, it will do 24-bit addresses. I just messed up. Anyways, yeah. So ADL, address and data long, it makes everything bigger. And that also means there's more space. So the TI-4 plus CE technically can have more space than all the other calculators for fancy new features. But yeah, a register will hold a number or some binary data. 8-bit, it holds well, 18 binary bits. These 24-bit registers, you can combine these. So imagine seeing like, here if I just Google this. Ben Eater, of course. Ben Eater is amazing. If you want to learn about electronics, go to him. Let's just pull up a picture by him, because why not? This is a thumbnail. I just copied the image address. I don't want to do that. But you can see here, this shows, I think that's showing a register. Yeah. These are different registers. Or these are registers, I can't remember. That's probably an AND gate, to be honest. Yeah. These are 4-bit registers. You can see from the diagram. You have 4 data lines and whatever, and I don't know. Yeah. 4 of these pins will input and output data. Oh, wait. I don't know. But, yeah. Imagine something like that in the computer, or in the, technically it's in the processor, but yeah. But you have these 8-bit registers. Imagine something like one of these inside the CPU. And when you reference a 24-bit register, that will reference all 3 of these, or similarly in the Z80 mode, because 16-bit, 2 8-bit registers, it combines them, and yeah, magic. I don't even know where I was going with this. Yeah. Oh, that's right. Yes, so right here, LDB04. So LD is an instruction. It means load. If you could tell by my comment, it will take the B register, so the 8-bit register, and also if the assembler, I have spasm. What it will do? I am very unorganized. I don't know what I'm doing. It'll go through all the instructions it knows, and that's all the instructions for the TI-84 or the eZ80. And it will find, oh, it'll be chugging along this file and it'll see LD. Alright, let's find the LD instructions. Alright, here's all the million LD instructions, load instruction. And we want just a single register. Oh, okay. Alright, here's the instructions that use just a single register. And then what's the output after that? Oh, that's just hexadecimal. So it's going to use this N. So this is where it comes to load register. It doesn't actually look through the PDF, but it will find load register. It will find that your specific, these opcodes is the actual hexadecimal that's used. So it saw that I used the B register, so it takes, we'll find the opcodes for it, and since I've actually looked at the code, it has everything printed out and whatever. Right here at JJ, you can go down to this table, and that has the specific register. So I want to load to the register B, so I replace JJ here with B, so 06, and NN is just whatever number. So if you were to actually look in the memory of the calculator where this program is located, you will find 06, 04. And then when the calculator CPU finds that, it will take 06, 04, and it will load 04 into the B register. That's basically assembly. There's more to it than that. There's a lot of different instructions. I mean, it's a 411-page document. Like, instructions start at 88, and they go all the way down to 382. So it's like 200 pages of instructions and their data. If you want to fall asleep sometime, or if you're having trouble falling asleep, just read this. Yeah, I'll back over here. Alright. We're doing good, boys. Girls, if you watch it later. So, you know, that's an assembler. That will take your assembly code and through a very long, complicated process, it will get the assembly. But I here have the ROM for my calculator. So this is what the calculator is loaded with. And I can scroll through this, look at all the hexadecimal. Technically distributing this is illegal, I believe. But this is only a section of it. And when I actually release this program, I will not have that ROM in there, but if someone does make their own ROM, or copy their own ROM, or whatever, if they get their own ROM, or they load up a program, what my disassembler will do, actually if I pull up, I close my calculator emulator, open that, and drag that over here, and don't do that. Qt is amazing. It goes to the very beginning. Actually, if I go over here to memory, you can see right here, F3 eD7E 5B. F3 eD7E. Oh my word, it's the same exact data. And then if we go here, F3 eD7E, but you see here they have the instructions. So an assembler will take the instructions and turn it into the data, but a disassembler, hence the disassembly panel down here, that will take your hexadecimal, your binary or whatever. We just use hexadecimal because, I mean, who wants to display 3 is 01001111. I mean, who wants to try and interpret that? Actually, I think with XXD, I don't know if I can just display binary. Well, I know I can. It's just a matter of how. Oh, it's bits. So if I set the bits flag, yeah. So imagine reading through all that. It's just a pain. I don't want that. So we use hexadecimal because it's shorter. Yeah. Sometimes you have to use binary, but that's special cases. So yeah, hexadecimal turns into instruction, and that's my goal. Because with this, scrolling is okay, but once you get going so far, you can either use your scroll wheel, or you can page down. Page down doesn't actually work. Or you can press the end button, which will go another instruction. You can hold it. Even the scroll wheel is a lot faster. If you drag the scroll bar and you just wiggle your mouse below the end of it, it'll go. But see, honestly, this is just kind of slow. And I'm gonna pull up that window here, move it back over here. There's a program, Binary Ninja, and it has this really cool feature called a flowchart. And what did that say? Oh. I thought that was like an open source version. I was like, what? Actually, I think you can use Binary Ninja open source. I'm not quite sure. But you can see here how it will show your instructions. We'll have a fancy chart that flows between. I mean, it's called a flowchart. But this is the disassembly for a C program. But this will display like different routines or whatever, and you can break it up. The end goal is to get something that looks sort of like this. But you have to start somewhere. But basically I'm trying, because there is one program I could use. Yeah, you can see here this shows things. But if I go to what's the program? Radere. It kind of sounds Italian. Radere. I don't know. But Radere, it's a program that's used to disassemble different programs. Like it'll disassemble C programs, and it has different architectures, which is the processor type. Yeah, disassembler. And there's different things. But with Radere, can I actually go to the Radere 2 website? There's Radare. Yeah, here's like the website for it. You can see here this has a disassembly view. A disassembler, you can view like the hexadecimal. But you see, doesn't oh, this is really nice. This has a flowchart. I'm gonna try to implement something like this. That's the goal. Oh, alright. That was, oh, I see what I did. I'm assuming these are different, like, yeah, I don't know. Well, I want to use this. That's an old thing. There's a new thing called Cutter, which is an interface for Vidare. That has a fancy flowchart and stuff. It also has extra like tools and stuff, which is pretty nice. And it's open source, and you can view all the source here. But you see, in order to use it for the eZ80, you have to, teach it the language. And it does have the Z80 language, based off of Vidare. So if we go Vidare.org, Vidare 2, I did this the other day. Lib.r, yeah. Assembly, arc, Z80. You can look at like all the code here. This will give information about, or this is the actual C code that the program will use for the eZ80. But I don't really, I can understand this because I've poked with C a little. But in order to write, in order for Vidare or even Cutter to understand the eZ80 code, it has to understand. You have to do that. And I don't know, I could potentially email someone and try to figure it out, or post an issue under GitHub. Even though it's not quite an issue, but you get the point. I can actually do it on iOS. Oh, you gotta use Cydia. Yeah, that makes sense. You can install this, but you have to have the, what do we call it? Yeah. Yeah, you have to teach it eZ80, and I don't know how to teach it eZ80, so I just said, screw it, I'm gonna make my own version, basically. Yeah, anyways, now that you have a full course in assembly, now let's go back to JavaScript and HTML, because we're making HTML elements. So before I had like a memory view, and I was just basically writing the memory to the screen and just making it fancy and having. Did I just? Oh man. Oh, are we live?